In this video, we want to prove that m factorial times n factorial is less than m plus n factorial. So let m and n be positive integers, and let's consider m plus n factorial over m factorial times n factorial. So what I did was I just divided both sides by m factorial times n factorial. Okay, well, I know that m plus n factorial is m plus n times n plus n minus 1 all the way to n plus 1 times n minus 1 times all the way up to 1. And now I can break this up, or I can group it together. This n times n minus 1 all the way up to n is just n factorial. And so I have an n factorial on the top, n factorial on the bottom. Those are going to cancel. And so I'm left with this. Now, let's rewrite m factorial. M factorial is m times n minus 1 times all the way up to 1. Now I can break this up. So looking at the first factors, we have m plus n over m. The second is m plus n minus 1 over n minus 1. And then I just did another one, m plus n minus 2, etc. And then these should be dots here. All the way up to m plus 1 over 1. Okay, so this is what I'm doing. I'm just grouping these guys. Now, I can rewrite this. Okay, so I'm going to leave the first one alone. But the second one, you have m plus n minus 1. I'm just going to write that as m minus 1 plus n. So basically, I'm taking this minus and moving it between the m and the n. So I'm doing that for most of the terms here. Okay, and now I can rewrite this. So m minus 1 plus n over m minus 1, you can think of that as m minus 1 over m minus 1 plus n over m minus 1. M minus 1 over m minus 1 is 1, and that's plus n over m minus 1. Okay, so I'm just doing that. And so at the last one here, it's just n plus 1 over 1. It's just n plus 1. So there's nothing special there. And then note that each vector is greater than 1. Well, why is that? Here I'm dividing n and m. N and m are positive. So when I divide two positive numbers, I get another positive number. Okay. So this is positive. 1 is positive. 1 plus a positive number is positive. Same thing with all of these guys. And at the end here, n is positive. Positive plus 1 is positive. So that's also positive. So then I'm just multiplying positive factors, which means everything has to be positive. So what we did was we considered this fraction, m plus n factorial over m factorial times n factorial. We said this has to be greater than 1. And so when I multiply both sides by m factorial times n factorial, I find that m plus n factorial is greater than m factorial times n factorial. Note that this is just in reverse. I can rewrite this as just m factorial times n factorial is less than m plus n factorial. And so this concludes the proof.